Hi and welcome. I'm trying to learn particle physics, and today the standard model, and after we've done it, we're going to do short impingement training. And if you participate in a short impingement training, this is your own risk. The story had begun in 1964 when theoretical physicist Mary Gell-Mann asked whether the protons and neutrons were already here. Now, that part was about that the new particles which were found seem to have no rules, and they seem to have not proper electrical charges. They seem to have 2/3 plus or minus 1/3. But now chromodynamics, this theory was brought up by Gell-Mann. Why should reality conform to such a whim, like having particles with plus 2/3 positive charge? The answer came with quantum chromodynamics, another term coined by Gell-Mann. It finally made quarks respectable by describing the interactions by the exchange of 8 gluons that carry a color charge, and showed how uniquely this force gets stronger the further you pull two quarks apart. Now, inside of these quarks, inside of the story had begun in 1964 when theoretical physicist Mary Gell-Mann asked whether the protons and neutrons that make up matter themselves consist of smaller stuff which he called quarks. So these protons inside are called quarks. And it finally made quarks respectable by describing the interactions by the exchange of 8 gluons. There are 8 gluons, and they carry a color charge, and he showed, and it was showed uniquely, that this force gets stronger the further you pull two quarks apart. These quarks inside of these protons, the further you pull them apart, the stronger gets the force pulling them together, and that is the explanation for why it could both explain that protons looked as if they were made of quarks, and why these quarks could never be pulled out of protons. So powerful we had. But we didn't really understand it. And that largely was it. Following a period of mind-boggling theoretical invention, the standard model was in place. There was the unified electroweak theory, to which all particles succumb, and quantum chromodynamics, which affects only quarks and gluons. Okay, the unified electroweak theory, I don't know the word succumb, for all the particles, and the quantum chromodynamics for the quarks and gluons. The equation of these two main theories had a powerful symmetry that dictated the character of nature's forces and told physicists what sort of new particles to look for and where. Okay, these both forces both together gave a symmetry, more or less. I'm thinking about how nature's forces work. One, why the protons could have different charge when one completely, and also how the forces are transmitted via electromagnetism, the photons for the whole universe, the electroweak holding between the electrons inside of the fermion, and the third force, the strong nuclear force holding the atom together. And now these electroweak and the chromodynamics, talking about how the quarks and gluons work. And that helped to explain the natural forces and helped to give physicists an indicator for where after what new particles to look. Sure enough, the bumps and particle collider data soon began to appear, together with goosebumps on the skin of the theorists. Evidence for free quarks had already been established in experiments in the late 60s. But by the end of the 70s, physicists in the US had inferred the existence of a fourth and fifth. Okay, sure enough, the bumps and particle collider data soon began to appear. Okay, the data we got from particle collision. Do I read from it? Appeared. So the data we got now from colliding different atoms together started to become problems to the whole thing. There was evidence, so scientific evidence, for at least 3 quarks in the 60s already, but by the 70s, I don't know really what the name inferred means actually. A 4th and 5th one were inferred. And finally, in 1995, physicists at the Tiverton Collider at Fermilab in Illinois found the 6th top quark. Okay, in 1995, a 6th quark was found, and it was called the top quark. By 2000, the tau neutrino, the last of the leptons to be discovered, had also been batched at Fermilab. Fermilab is a scientific institution in Illinois. It is a Tiverton Collider. Okay, in Illinois, in the United States, in the state Illinois, there is the there's the University Fermilab, and there's the Tiverton Collider. And there the 6th one was found. The 5th and the 6th one. On the other side of the pond, the gluon was snared at the Daisy Laboratory outside in Hamburg in Germany in 1979. Is there just one gluon? One gluon. Okay, no, here was something about more gluons. Okay, one gluon or whatever was found in Europe, not in the United States, in Europe, in Hamburg in Germany. There is a DSI laboratory in Hamburg, a city in Germany. In 1979 was it then. Okay, we're going to start with a short impingement training. If you were here for particle physics, you're going to go directly to the next part where we will talk again about particle physics. We will do now the short impingement training. If you participate in the short impingement training, that's at the office. Next, we don't try to provide a part of it doing forward short circuits. We go back, and down. And the last one, back, up, and down, and backwards. And the last. Now we're making advanced shoulder circuits, long arms, strong fists, and go as far back as you can with the shoulders. As high up as possible. As far in front as possible. And down. And back. Up. And front. And down. And now backwards. Up. Back. And down. And in front. Up. Back. Down. Next exercise. Legs wide apart. Go to the knees. Inch forward with a straight back. Let the arms hang and pinch the scapulars together. Now make fists. Lift the arms up and pinch the scapulars together. The arms down and the scapulars. And the second one. Pinch the scapulars together. Make fists. Lift the arms up and still pinch the scapulars together. The arms down. And this is an exercise. Into the knees. Forward, this time with the round back. Let the arms hang. Make fists, turn the fists to the inside. Let the arms up and bring them together. Straighten up, bring your shoulders down, and together. The arms high up and together. Shoulders down, and together. And release. And the same time. Into the knees, hinge forward. And the round back as the arms hang. Make fists. Bring the arms to the inside, the arms high up and together. Straighten slowly up, bring the shoulders down and together. The arms high up and together. Shoulders down and together. And release. And now the arms up. And all we're doing is to observe what the scapulars are doing. If this exercise causes pain, then don't do it. Again, the arms up. And down. And again up. And down. And something similar. Arms at the side and the arms in front. shoulders should go now back together with scapulars. Now a bit to the outside of the ribcage and back together again. The last time in front and back. Now we're vertical. Golden stable stand. Strong arms, long fists. What's it hard? Long arms, strong fists, and bring the shoulders down together and turn the arms to the inside. And now the arms to the outside, the shoulders down and together. Again, the arms to the inside, shoulders down and together. And change the last side. Arms to the outside, shoulders down and together. And now something similar. The arms to the outside, fists a bit in front, bring the arms in front, bring your shoulders down, together. Now the arms back, shoulders up in the front. And the arms in front, shoulders down, together. The arms get back, shoulders up and in front. And we're doing the shrug. Lift the arms up and shrug the shoulders. Lift it up again. Again, the arms up. Shoulders. And the last time. The arms up, shoulders up, release all out. And we're doing a practical. Arms together and bring them down into the outside. And back together, the inside, to the outside. And this was the last time. Now we're going to do Sunday. Take a sock, whatever, tennis ball, a t-shirt, have a long arm ball, and let it fall down. Try to catch it again. And on the other side. And we're stretching. And bring one arm in front, shoulders back, down. Pull your arm in, have his fingers. Touch your legs, the arm. Go, break the shoulder. And that's with it. The shoulders back and down, pull the arm in, have his fingers. Touch your legs, the arm, go, break the shoulder. Okay, the other arm. Shoulders back, down, pull the arm in, have his fingers. Try to relax the arm. Now get back to the shoulder. And that was the shoulder training. I thank you very much and until next time.